Listening to Jeremy Louis is going to tell us why all platforms need AI Copilot components. Our talks here this afternoon are going to be 25, 30 minutes with another 5 minutes of Q&A. So make sure you have your questions ready. I'll come around with a microphone and make sure that you get your questions answered. Jeremy, take it away.
Great. So thank you all very much for coming today. I'm going to be talking about why software platforms need AI copilots. And there's really two things I want you to take away from this talk, or hope you take away from this talk. The first is that this is a very principled use of AI. We're not just jumping on that AI hype train. And the second is, how can we actually go about building these AI copilots? And so to get started, I'm going to give you a demo of an AI copilot I've built, which is Foyle.io, and helps you operate your software. So this is my Hello World service. It is deployed and running in production. That's how you can tell from the prod path. This service is incredibly simple. It just gives you Hello World every time you access the page. We're using AI to generate this greeting. We're using AI because why wouldn't you use AI today to generate Hello World? So you can see that every time I reload the page, I get a different greeting. So everything's nice and working well in production. But let's check staging. So we're getting that no healthy upstream error. So now what I'm going to do is I'm going to go ahead and debug and hopefully fix that issue. And as I do that, I'm going to show you how Foyle, this AI copilot, can help you do that. So to get started, I go over to vscode, and I create a document, which is a markdown document. And I'll call that fixstaging.md. And since I'm using an extension called RunMe, this markdown document opens up as a VS Code notebook, so I can start writing markdown cells to describe the problem in my thought process, as well as code cells that I can actually execute to accomplish different tasks. And since it's a markdown document, this produces an artifact that I can share, for example, as my postmortem or to attach to a bug report. So to get started, I'm just going to start a markdown cell, and I'm going to describe the problem I want to fix. So in this case, fix staging, Rube service. Why am I getting no healthy upstream error? And so what you'll notice is that as soon as I start typing, I get this go cell. This is that was the text that was lightly grayed out in a code cell. And this is the suggestion from Foyle, the AI, about what commands I might want to run in order to accomplish my intent. So this experience should be very familiar to anybody who's used any of the existing Copilot tools out there, like GitHub Copilot. The only difference is instead of completing your current cell or from where your current cursor is, Foyle is going to actually suggest new code cells. So in this case, Foyle is giving me a helpful logging command to fetch the logs using gcloud. And there's a couple things that I want to point out about this suggestion that came from Foyle. If we look at this query, we can see that there's some query clauses that indicate some knowledge of how the Rube service is running and how it's deployed. So the first clause is it's filtering down to the logs that come from Kubernetes containers. So it knows that I'm running on Kubernetes. And it also knows what the labels schema for my service is, because it knows how I've labeled my pods in order to identify both the application as well as the environment. And so this happens because every time you execute commands inside RunMe and Foyle, Foyle is constantly learning, and therefore it learns about your platform and infrastructure. This is critical because everybody's platform and infrastructure is different. And so if we want the AI to give us helpful suggestions, it needs to know how we're actually running and deploying infrastructure in our systems. So let's go ahead and run that command. And so this is one of the really nice things about RunMe is that we've created this single pane of glass for operating things. And this allows us to execute commands directly from the notebook. So we can see here that the logs are actually empty. And the logs are empty because we were filtering for errors. So there was no errors in our logs. And so what happened next is we got another go cell. And what this go cell is, this is Foyle analyzing the output of the previous steps and telling us what we should do next. And so in this case, because we got no errors inside our logs, Foyle is suggesting that we should look at the pods next. So let's look at the pods. And we can see that we've gotten an error. Let's see, 1 second. And so what we got next was we got another go cell, which I have accepted. And this go cell is Foyle analyzing the error, the output, and telling us what to do next. So in this case, you can see that Foyle is analyzing the error and telling us the pod has an invalid image name status. And this suggests that there might be an issue with the Docker image name specified in the deployment manifest. And that to resolve this issue, we should look at the image name in order to see if it's correct or not. And it's given a bunch of commands to us to actually go about looking at the actual pods. But in this case, I'm going to give Foyle a little bit of a nudge, and I'm going to say, use kubectl to just get the image name from the pods. And I'm going to do that mainly just because it's going to be easier from demo purposes to see what the output is. So let's go ahead and execute that. So here's the image name that it's being used. And we can see that there's a couple problems here with the image. First, the separation between the image name and the tag is the @ symbol, which is not correct. It should be the colon. And there shouldn't be a period in the v1 command. And so we have to fix the image. And it looks like Foyle has helpfully given us a command to fix the image. Let's go ahead and run that command. So it's updated the image. Now let's check the pods. Let's see if it's trying to get. So you can see that it gave us the wrong command. It gave us the logs command. So let's see if we can do the get pods. So now we can see that it looks like our pod has started, and it's nice and healthy. So let's go back and check. So great. Our staging service is back up and running. Let's try our dev instance. So our dev instance is also down and unhealthy, and it's giving us the exact same error. So let's go ahead and debug that the same way. So we'll go over here. We'll create a document, fixdev.markdown. So not surprisingly, we're getting the exact same suggestion from Foyle that since we have the same problem, we want to probably start off the same way, which is by checking the logs. So let's go ahead and execute that command. So this time we see that something different is going on because our log's showing an error. And so what's happening is we can see that there's an error inside the logs, and that error is indicating that there is a problem accessing the secret in Google Cloud Secret Manager. Because remember, we're using AI to generate the greeting. In order to do that, we need an OpenAI API key. That key is stored in Google Cloud Secret Manager, and therefore we need to make sure our pod has permissions. And so what Foyle is telling us is that the next thing we need to do is to check the service account configuration to see what's going on. And we can see here that it's made another slight mistake in the analysis here. It's looking at the default service account, and we actually want to be using the Rube service account. So let's go ahead and run that. So we've gotten that command. And so here we have now an analysis of what's going on. And so it's telling us that the logs indicate that there's a permission issue with accessing the secret, the RubeDev OpenAI API key. So it's pulling that out of the logs. And it's telling us that we need the permission secret manager versions.access. And so it's telling us that to debug this, we need to check the IAM permissions on the service account to see why we don't have the correct permissions. And it's given us the IAM command. It looks like made a mistake in the service account, so let's go ahead and fix that. So we ran that command, and it's given us that, and we're seeing that we don't have any bindings except for the workload identity user. So next, Foyle is analyzing that, and it's telling us that we need to add the secret manager, secret accessor role. And if we look, we can see that it's actually given us a Google Cloud command to add that IAM policy. That command is correct, but we don't actually want to use it because we're actually using Terraform to manage our IAM policies. So we'll give Foyle a nudge. We'll say use Terraform. And so we can see here that it updated it. And so now we have a Terraform policy that it's adding to our Terraform file. It looks like it got the secret wrong. So we're going to go in and fix that. So now we're just telling it to apply the Terraform policy. So we're just waiting for it to apply. Looks like that is successfully applied. So now we will restart the pod so the changes take effect. So it looks like the pods have restarted, so now let's check them. So it's suggesting the commands to check the pods. It looks like it got the label wrong, so let's fix that. And I think this is one of the important things about the experience that we've tried to create with Foyle is AIs do make mistakes. And so we've tried to create an experience where it's very easy to interact with the AI and correct it when it makes mistakes while still getting value. So we can see that our dev pod is up and running. So let's go back and check it. And great. The dev service is back and healthy. So hopefully that demo showed you that, like, hey, if we have these AI copilots, they can really help us walk through the problems that we're trying to solve and help us figure out what are the individual steps we need to run in order to accomplish our intent, and that the AI will automatically adapt based on the output and the actual situation that we're dealing with. So now let's talk a little bit more about the why and the how that underpins this. Let's start by why use AI. There's a lot of hype right now around AI. It's not unlike Kubernetes maybe 5 or 6 years ago. And it's easy to think like, hey, we should just sprinkle a little bit of AI fairy dust on whatever problem we have, and it's going to magically be solved for us. But I think in this particular case, we're using AI in a very principled way. We have a problem that is well suited for today's technologies like LLMs. And so I hope you walk away from this talk with an answer to this question that really shows that this is a principled use. So I'm a software engineer. My job is relatively simple. I start by writing software. I then ship this into production. And then we make money. And today, in large part because of AI, writing software has never been easier, right? We have all these copilots and AI assistants that make it super easy to write code in languages that you may not even know, and very easy to help you learn them. And so in our case, for that Hello World service, any of the assistants can write that code very easily. But when it comes to shipping this software and operating it in production, it's still a little bit of a nightmare. We're still solving this not so much with AI, but by giving our application developers a whole bunch of tools, as kind of illustrated by the CNCF landscape. And we're kind of saying, have fun. Like, figure out how to use all these tools to solve all of the problems you have with them. when they're operating and that software in production. And we can see that if we look at what does it take to actually get this Hello World service into production. So I wrote some Go code. And once I had that Go code, I had to build a Docker container and push it to an artifact registry, which I did using Co. Since I wanted to deploy this on Kubernetes, I had to create a Kubernetes deployment resource and also a Kubernetes cluster if I didn't already have one. Since I needed an OpenAI API key, I had to put this into Google Cloud Secret Manager. I then had to create appropriate IAM policies and workload binding in order to give the deployment pod access to this secret. And then to actually expose this to the world, I had to create all these networking resources. I don't think we can solve this complexity by building more tools, because we've been building tools for the past 20 years to try to simplify operating and deploying our software. And it's kind of how we wound up in the situation we are right now, where we look at the CNCF landscape and we're just overwhelmed trying to make sense of all of that and figure out how to accomplish our tasks. So I think in order to make shipping and operating software easier, we need to make it easier to use our existing tools and to make them more accessible to application developers so they can focus more on the application and business problem they're trying to solve and not this burden of learning all of these tools. I think the way that we make tools easier to use is with playbooks. If you have a playbook that tells you exactly what you need to do, then you can just sort of copy and paste the commands and sort of blindly follow that playbook. So for Hello World, you can imagine I have a playbook that tells me, step 1, run co-build. Step 2, run kubectl apply for these resources. And step 3, run Terraform apply to create all of the cloud resources that we need, like the IAM policies. The problem is we can't keep up in terms of writing these playbooks. And the problem is, because of all of these tools and complexity these days in cloud and Kubernetes, we have combinatorial complexity, where depending on what you're trying to do or what kind of tools you're doing, there's all this different branching that could be going on. And hopefully you got a sense of this from the demo, because we had 2 different cases where we had the same exact error, no healthy upstream. We started off our debugging process the exact same way in both cases by getting the logs. But then based on whether there was an error in the logs or not, we started going down different branches. And this process of branching would continue at every step of the process. So we no longer really have linear information flows, which makes it really difficult from a documentation writer to figure out how do we organize and structure this information. And it's also really difficult from the reader to try to figure out how do I follow this choose your own adventure process to figure out how to actually accomplish my task. So this is a problem that I think generative AI is perfect for solving, because I think we can use generative AI to write our playbooks. And it's not just that we can use generative AI to write our playbooks, we can do so dynamically and sort of generate our playbooks just in time so that our playbook is personalized and adapted to the specific issue that we're seeing. So it's analyzing based on the output of the commands we've just run what we need to do next. And the insight really here is that this is basically a sequence prediction problem, which today's LLMs are perfect for solving. So if we have some intent, like debug no healthy upstream, we can feed that to an LLM and ask the LLM, what's the command I should run next to debug this? And the LLM can spit out the command we should execute. We can then execute that command and collect that output. And we can then feed that back to the LLM to say, all right, given this output, what should we do next? And so by iteratively repeating this process, we can build an AI that walks us through the process of accomplishing our intent. So all we need to do this is data. If we have these traces, these reasoning traces of intent, command, output, these sequences, we could just train an AI, an LLM, to solve our problems. So what we've done is we've created an IDE for operations using RunMe and vscode that creates a better experience for operating your applications, because we give you a single pane of glass that combines executing commands and looking at the output, and also produces artifacts that you can share. And as a side effect of using this IDE to solve your problems, we can collect all of the data we need in order to train the LLM. So your markdown cells capture your intent. Your command cells capture the commands you needed to actually execute to achieve that intent. And we can then capture the outputs of those commands as well. So we can capture that data and use that to train the LLM. A key bit here is we really want high quality data. And the key to getting high quality data is collecting human feedback. And in Foyle, we do this because when we suggest a command, as is evidenced by the go cell, the human accepts the command, and then the human can edit the command. And so we can log that signal, and based on that logging, we can identify what were the intents where the LLM made a wrong prediction, what was the correct prediction that we should have predicted, and we can then use that to retrain the AI. And if we do this, we create this data flywheel where the more you use Foyle and RunMe, the more data we produce. The more data we produce, the more we can retrain and produce a better AI for assisting you. As the AI gets better, you derive more value from it, and you're going to be more inclined to use it, thereby producing more data. It's very early days for Foyle and RunMe for Foyle, but I find that when I use it, it saves me a fair bit of time. So I estimate it saves me about 20 to 40 minutes per day. And this is based on the number of times it makes a suggestion that I end up accepting. So at the bottom of the slide, you can see a graph of how many suggestions it makes each day that I accept. And right now, it's about 20 to 40. So I could really use your help. I'd love for you to try it out. The folks at Stateful have created this amazing sandbox, which is at this URL, stateful.com/Foyle, or the QR code will take you directly to it. You can basically open it up in a web browser, and you can try out RunMe and Foyle without having to install anything locally. But I'd also love it if you tried out Foyle yourself, if you wanted to try it on your own machines. It's very easy to install. You have to install the vscode extension for RunMe, and then you download and run the Go binary for Foyle. So everything runs locally, so you don't have to worry about sending any data to anybody else. And after you've tried it out, I'd love it if you provided feedback. You can find us on GitHub at jlouis/Foyle. I'm on Blue Sky, jeremy.louis.us. That's also my email. And then really, I'd love to talk to people here at KubeCon. I'll be hanging out at the Stateful booth, which will be S51. Just a couple quick shout outs. I really want to acknowledge the Mozilla Builder Accelerator, which has been graciously funding my work with a grant. And then Stateful and RunMe, which is the open source VS Code extension that provides the front end. They've been really great partners. And with that, I will pause and say if you have any questions.
That was super interesting. Thank you for the talk. One of our challenges that we've seen in kind of using AI for platform is that many times the commands are out of date, especially once you're trying to troubleshoot harder things. What's your take on that? Like, is that something that you've kind of feed the model to have newer data, or is it more just waiting for it to catch up?
So I think when you use this approach, right, it changes what it means for us to be as platform engineers. So if I think about platform engineers, the two terms that constantly come up was paved path and guardrails, right? So you can imagine we have a better way of doing, we have an old way of doing something, and now we have the better way of doing something. And now we really want the AI to come up to speed so that it starts spreading that knowledge around. And so what I think that means for us as platform engineers, it really means how do we curate the AI so that it quickly learns the new way of doing things and spreads it. And so I think the way that we achieve that is by retraining the AI, but also using data curation. So we can, if we have examples of like running the command or achieving the intent using the old way, then as platform engineers, we want to start curating that data when there's a new way, rewriting those examples to use the correct new way, and then using that data to retrain the AI. So that's how I think we solve that problem.
This was a really interesting talk. Thank you for that. I would love to get some context on like how Foyle works behind the scenes. Like you could see in the commands, it knew that you were running gcloud and it knew the labels of your pods and all. So are you basically like reading the code in the directory and then maybe sending it to OpenAI API and then getting a response? Like how are the responses actually generated?
Yeah, the AI is actually very simple. We basically use context-dependent few-shot prompting, right? So that's a little bit of a mouthful. It sounds fancy, but it's very simple, right? We basically have a RAG database of past examples of intent action pairs, right? So what was the intent? Debug no healthy upstream. And then what was the actual command that you ran, such as the gcloud command? And then what happens is when you execute a command, we look up relevant examples as a way of informing the AI, and then we feed that as a prompt to OpenAI or whatever model provider you choose. You can go check out the prompt in the repo. It's fairly simple. We basically say, continue writing this document, right? So suggest markdown cells or code cells to add to it. And here's a couple of examples of similar documents or fragments of documents that you might be helpful. So that's it. It's pretty simple.
We've got time for one more question. Anybody else? Great.
I'm just wondering how this meshes with like opinionated systems that kind of sit in front of, platforms or infrastructure. So guardrails type systems.
Yeah, so I think if you have existing tools, it should play well with those, right? So we've tried to create an experience that works really well with CLIs and all the APIs that you can interact with via CLIs. So if you built like some higher level CLI rather than like kubectl or to like produce configuration according to some guardrail or paved path for spinning up applications, Foyle would learn that. So when you say like, give me an app template, it would use your custom CLI or et cetera to do that. So I think it would play very well.
Great, super interesting talk. AI is such a big theme. So thank you so much. Let's give him a round of applause.
Thank you all.